everybody, and welcome to another episode of React Wednesdays. I am TJ Van Tol. I work as a developer advocate at Progress. And with me today, as always, let's go bottom right here, is Dan Wilson.
Hey, I'm Dan Wilson. I work with Digital Primates, and we do enterprise React stuff. We also curate the Enterprise React newsletter, which is where I found David and his great XState project that we'll talk about today. If it's your kind of thing, Google it, sign up. We don't sell your email address.
Also with us today is Christian, returning champion, Christian Pillsbury.
Hello. I'm also a senior consultant at Digital Primates, and I was the one who recommended putting some XState on our newsletter.
Awesome. And our special guest today is David K. And we just learned that the piano in your name is actually because you actually majored in piano, correct?
Yeah, that's right. So when I went to university, I majored in piano performance, and you could see this way, piano bench right there. So yeah.
Very cool. So I know we want to talk about state machines today, which I'm very excited about because I feel like it's a topic that I've heard about a lot, but I've never totally understood, or it's never really clicked for me. So maybe you could just set the stage for us as if for people that are joining that have no idea what state machines even are, or why you might use them, or what XState even is. Maybe you could just start by setting the stage for us on all of this.
All right. Well, I'll actually make a really, really simple real life example. So you could be in one of two states, either asleep or awake. I don't know anyone who's managed to be both awake and asleep at the same time, but it's just this idea that you could only be in one of a finite number of states at a time. And also the idea that you could transition between those states, like sleeping and, like when you're awake, you could go to sleep and then you're asleep, and then you could wake up and then you're awake. And also these finite states are special because you could only do certain things when you're in a state. For example, let's say someone told you to cook lunch or something, right? Obviously, you could only do that when you're awake. You can't do that when you're asleep. And so this is a real life example, just because state machines really describe, pretty much everything in real life. But they also describe the logic of our applications. Like, for example, when a button is disabled, we want to make sure that when it's in that disabled state, nothing should happen when you click it, right? And obviously, there are buttons that sort of violate this rule, but that's the general idea. Just there being a finite set of states, a finite set of events or things that you could do to that state machine, transitions between states and other states based on those events. And so that whole collection of things just makes up what's called a finite state machine. And it's a really old concept. It's like 50 or 60 years old, if not, older.
Yeah, I really like there's a comparison to the old Walkman, and like when you press the stop button, like when can you fast forward, when can you not? If it's ejected, like if the thing is open, right, you can't hit play. It actually, it was a good design. It actually wouldn't press down the play button, so you actually weren't like physically able to do it. So it's
right. Yeah, and so that's what's also known as a mechanical automaton. And so what's interesting is like this whole idea of like being only in one state at a time and a machine actually doing something. A finite automaton actually predates electronics. So there's like these wooden toys where you spin a thing and they dance and they do stuff, and those are known as automatons. So it's basically the same thing, and that's where finite state automaton comes from.
That's cool.
So when it comes to the actual coding part of this, like that sort of makes sense to me at a high level, but when you're actually developing, is this like a way of approaching code so that you're not just writing a bunch of if checks? Because like in my mind, it's like, okay, I can't do anything while the button's disabled. So then in my logic, like my brain at least logically goes to like, oh, well, then I'll just wrap this with an if not disabled check. But I imagine this starts to get into like, well, like for more complex examples, right, you could have a lot of different state and a lot of different checks. Is that sort of where we're going with this? Like these more like lots of moving pieces situation?
Sort of, yeah. And that's actually a really good intuition, because when we're programming, we are already making finite state machines. We're just doing so in a very implicit way. There is the defensive programming approach where you just litter your code with if statements, basically making sure, taking the example, like you're either asleep or awake. Like if someone tells me to cook a meal, make sure I'm not asleep first. And the problem is that sometimes that if statement comes after the fact, where it's like, we told David to cook a meal while he was asleep once, and that did not go well. So we need to add that switch statement to make sure we don't make that mistake again. So eventually you graduate from if statements to switch statements, and then you really delineate like what specific things can happen. And so I don't know if you're used to like Redux or something like that, but typically you would write switch statements where based on this event, do this, based on another events, do that. And state machines just takes that one step further, where instead of doing an events first approach, you do a state first approach. Be like, when David is in the awake state, here's all the things that he could do. And when he's in the asleep state, here's what he could do. Maybe he could transition to the awake state, and so on and so forth. So also, you don't need a library to implement this. If you search state machine in virtually any language, you're going to see patterns similar to a switch statement or whatever other language constructs are provided by that language that allow you to implement state machines. It's essentially a data structure. It's nothing special. So.
Well, I know you wanted to show some of this off, so maybe we could switch over to you showing some of this, because that might help make this a little bit more concrete.
Yeah, I have a feeling most of the audience are kind of thinking, okay, great, state machines, but how does it change what I've already done?
Sure. So I could go ahead and just make sure I have the right screen here. All right, there we go. So.
Yep. And okay. The audience should be seeing it now.
Mm-hmm. So I have a very, very simple example. And honestly, this is something that you would typically just jump straight into use state for. Let's say I have an alarm app and I want to turn an alarm off and on. First of all, just to show you how this works, I have a data state equals inactive, active. And this is our first clue that, we're dealing with finite states. But right now, we're not doing anything special. We're just, switching back and forth between inactive and active. So let's say that the business requirement here is I want this button to toggle this alarm on and off, right? So we could say const, this is just the way you would normally do it. So toggled, set toggled, or is active. A lot of people love using these Boolean flags, like the is whatever. So I'll just.
Oh man, I use them like crazy.
Yeah, you'll soon realize that like if you have more than two states, it's not really sufficient. And I'll demonstrate that here too. So we could use state false, right? And then over here we could say is active. If I make a mistake, it's because my hands are freezing, because it's actually cold in Florida. It's like 40 degrees Fahrenheit, which is, this is what kills Floridians. Just almost freezing temperatures. It's terrible. So my hands are still thawing.
Christian and I are both Floridians, and so we agree with you.
Well,
TJ, however,
Chicago though, so I don't agree with you anymore. But I remember your pain.
And TJ is from Michigan, so he thinks of 40 degrees as a nice balmy summer day.
Yep.
I was actually born in Chicago, so I should be used to this, but I moved when I was 8 and I haven't been back. I only been back once or twice since, but yeah. Okay, so our alarm app is working. You might think, all right, this is sufficient. This is all I need, just a simple little use state and a toggle over here. And as I said, this is sufficient when you have two states, right? Off or on. But not everything is like that. Let's say that we had this alarm app connected to many, IoT devices or something like that, and we want to save this to the cloud. So now we have three states. And I've seen people doing terrible stuff like, treating true, false, and null as like a triple Boolean, which this is a crime. You should be arrested for this. But
boxes in design.
So let's say that we want to have a way to have some sort of pending state where it's like saving to the cloud. And I already have a data state equals saving in the styles. So so we have to refactor this. And so instead of having true or false, we could have inactive. So we could say that this is either inactive, or it's saving, or it's active. So now we have 3 possible states that we could have this. And so we could say that this is instead status.
Right. So effectively an ad hoc enumeration of the possible states.
Exactly. Yeah. If you're using TypeScript, this becomes easy. Otherwise, you could have like const states equal like inactive, but that becomes very verbose. So we're just going to have it as strings, but you could implement those enums however you want. And so let's say set is active to saving once we click it, or we have to do this. And this is what TJ, you were talking about at the beginning, using if, else if statements. So we have to say if status is not equal to, or if status is equal to inactive, then we want to set is active to saving, right?
Yeah, you got to guard against that.
Exactly. So right now it's inactive. When we click, it fades out. And so now typically what we would do is we would have some sort of API call and then manually set it back to active. So I'm just going to put a use effect in here to do that. And we are going to, let's just fake this with a set timeout. So we're going to say set, oops.
Just don't unmount while you're doing it.
Yep, we have to remember our unmount and all of that.
And
so,
actually, if you could bump up the font size like 1 notch, that would be helpful.
All right, are people complaining in the chat?
Oh no,
you're all
that's
remote.
just me.
Bring your monitors closer to you.
Adjust my glasses here.
Okay, no worries. So we're going to set the status to active after 1 second should be enough. And of course, we need to have our cleanup. And this is honestly really annoying to do. Like I've done this a million times, so I just
it's
that and then clear timeouts and we have to do this if our status changes. So basically, if the status is not equal to saving, then return. So now we have 2 areas where we're having this defensive programming, all of this if statements, right? If status equals this, if status equals that. And so it becomes really difficult to, to clearly show where the logic is. And so I'm going to say over here, else set status inactive. So click here. After a while, it goes active. And then I could click to make it inactive again. And then I click here, it goes active. Now, let me ask you, can you see any sort of bugs with this? I mean, it works, right? But is there one bug that, might bite you in the butt later?
Christian's compiling. I will say that about 40% of the code that was on the screen was related to conditional Booleans for states.
Right.
And that's kind of annoying because when you go back through to try to figure out why something's breaking, you now have to parse all these Booleans and hold all this stuff in your head to try to figure out where the false condition is or where the action is that you don't want. And it just seems clunky. Although I will confess to having written many if statements in my life that probably shouldn't have been there.
Right. And so the way developers would look at this would be like, you know what? Yes, the if statements are annoying. I'm doing a lot of defensive programming. I'm not sure of any better patterns, but this works. So the typical wisdom in programming is if something works, don't touch it. Just leave it alone. It just works,
Also, it feels like, if those are you could also excuse it by saying, well, these are the requirements, right? Like I have these things, so of course I need if checks because this is just the way it has to work, sort of thing. At least I might approach it that way, possibly.
Yeah, I think people do write code the way that they think, not the way that they read. And so they've optimized for how it is in their head. and
Mhm.
not so much how you might try to like gather the context from reading code you didn't write.
Right. Yeah. So, honestly, all of our business, logic, use cases, whatever, they're covered in here. But I'm going to show you a bug that really only happens if you've either run into this issue like 100 times before, or if one of your users inevitably runs into this issue. So I'm going to turn the alarm on, but I'm like, you know what? Never mind. Let's turn it off.
Yeah.
Oh, it actually did clear the timeout. So if you're not careful about like clearing this timeout, then you might get this race condition where it actually should set it to active. I guess I have to save it to do that. Okay, so if oh, see? Do you see what happened there? So it was saving.
And then it toggled again.
And then it toggled to active already. And obviously you could fix this by doing that. So saying, if the status is not equal saving, it's going to clear that timeout. But that's really indirect logic. It's not really clear that, we could naturally prevent that from happening. So let's jump into actually using a state machine. And I just want to mention that doing this const status set status, this is a really good first step to just using the idea of a finite state machine in your application. But as we saw, our transitions aren't explicit, but our states are explicit. So
you have an enumeration of possible states, in fact.
Exactly. So what I'm going to do is I'm going to use XState, which is a library I created for making finite state machines and state charts, regardless of framework. So it doesn't really matter if you use this with XState or Vue or Svelte or Angular, it's just going to work. So I'm going to create a let's call it a alarm machine. And this is going to be create machine. And so what you give this is it's basically a JSON object. You give it an initial state. So let's call this inactive. And we've already gone through our states here. So you just put each of those in an object. So we have inactive, saving, and active. And so one good pattern over here, you would typically move from use state to use reducer and actually make each of these explicit events or dispatching explicit events instead of manually changing the state, because then we get to problems, or we avoid problems like we just saw there. And so the way that we could do transitions is we say on, and so it sort of reads just like a normal English sentence where you say on toggle, go to saving. Oops, extra colon over there. And then when we're in the active state, on toggle, go to inactive. And so we could say the same thing here. So if we're saving and we toggle, then we want the logic here to go to back to inactive. Of course, we could remove this and be like, you're not allowed to touch the button while it's saving, but that's up to your business logic. So
and real quick, what is toggle called here? Is that like an event or?
Yes. So that would be an event. And yeah, actually it might be good to just visualize this for you. So if I go to XState Viz, which here we go. This is an older visualizer, by the way. I'm working on updating it. But if I were to just paste this machine in here and click update, now we clearly see how each state can move between each other. So we have saving. And so if I wanted to say, you know what, let's make a saved event, and that should go to active, and we update. Now we could see that the way to get to active, we toggle, have the save event occurred, and then we could go back to it being inactive. And so that's a visual representation of our machine.
If you look at TJ, he's going to try to pasting in his many if statements into this visualizer. Try to get the same response. Can he fork that code? Can you change it?
Oh yeah. So you could log in, update it. What it does is it saves to gists. So you would log in with your GitHub account, and the only thing this visualizer does is request read-write access to gists, and then it just saves for you. So yeah,
so with this visualizer, you can kind of walk through your states and how to get there. That's outside of the code perspective and even outside of the application perspective. So you can make sure that your chains or your changes in state all make sense. And then you can put that back in your application without having to, once again, use the application to test the states.
Right, yeah. But so like I said, this was the old visualizer, and the going back and forth between the visualizer, it's extremely useful, but after a while it gets annoying because you're doing a lot of copy and pasting. So I'm going to actually show you a really cool solution for that pretty soon. But let's get rid of all this code first. So I'm going to say const state send equals use machine. And so this use machine hook comes from XState React. And if you know how to use reducer, I hate that they start with use. If you know how to, put in use reducer in your applications, then use machine is going to feel very familiar. You could think of a machine as a superpowered reducer, by the way, that handles side effects and all sorts of stuff, but it's essentially the same thing.
If nothing else, it's just an awesome API name. Like use machine, it just sounds really cool.
Yeah.
Yeah, it's a slightly different paradigm because of the way that the relationship between the imperative and the functional works, but it's a good reference point, definitely.
Yeah. So let me just show you what this state looks like. So when we use machine, we are going to get a state object, and sorry, the font is a little smaller than what's over here, but the important part is you get like this value of inactive, and you also get the event that just happened. But the important thing is that value and the context, if we're actually dealing with external data and not just, or extended data and not just finite states. But if we actually use this in here, then instead of doing this Boolean logic like if, else, all that sort of stuff, we could just say that clicking this button means that we are sending a toggle event.
Right.
You could also send a type toggle object, but if it doesn't have any payload, then I don't know. I like being lazy and just sending a string.
Shorthanded.
Yeah. So let's see what this does. When we click this, it will go to the saved state, and I'm just going to simulate like a 1 second going to active over here. I'm just going to say after 1,000 milliseconds, go to active, just for demonstration purposes. And I have to put that colon over there. So now I click here, and then it goes to active. Then notice what happened. In the active state, the exact same toggle events moved me back to the inactive state. And so you could see over here that there's a whole lot of nothing. And that's because all of the logic is over here in our alarm machine. We don't need this anymore. This send toggle can be called, pretty much anywhere where, where you have access to this send. And if we have the logic where if we're in the saving state and we toggle again, we go to inactive, then we see that, it's not going to do that, mistake where it goes to active.
Right. And you've also completely decoupled your business logic from being deeply tied to the code that's just about React. So you were mentioning before, well, first we were looking at a visualizer. Guess what? We can visualize the business logic completely independent of any particular application or view implementation. But also you were pointing out that you can use XState with Vue or Angular or whatever, and now this code has nothing specific to do with React and React hooks, other than the fact that that's where you're telling things to like send the particular action. So there's a lot of value of like having it defined completely independent. And it's also completely serializable because, as you pointed out, that it's basically JSON.
Yeah, and those are really good points. And when I tell developers that, they think, that's cool. It's like sort of the same thing as saying like, oh, you could, do time travel debugging, or your functions are pure and whatever. It's like those sound cool. Those are good buzzwords, but what benefit does does having my entire business logic externalized actually give me, when the way I was programming before works just fine, or at least for the most part, save those few edge cases. And so just to demonstrate, let's say that I import, I have an inspect here from XState inspect. And this is something that I created a couple months ago. It's an inspector utility that allows you to visualize a machine in real time as you're running your app. And so the way that this works, I'm just going to call inspect with iframe false. By default, it looks for an iframe and it puts the state machine directly into the iframe. And then I have to set dev tools to true. And the reason you do this is because obviously you don't want this running in a production environment. But once I save, what it does is it opens up this visualizer that shows you, let me just try to put this side by side. So if I put this here, and I put that here, it's a really tiny alarm, but here's the visualizer. And this machine shows what's happening in the application as we're playing with it.
Super
Holy
cool.
crap.
I'm so glad you built that.
Thanks. So, we could go here and we could see, okay, that's happening. We have a record of all of the events that are happening here, which, they're pretty simple, and a sequence diagram of the events too. This is useful for more advanced use cases where if you're invoking or spawning different machines, then you would see them sending events to each other. But also, we could control the app directly with this as well. So we could, toggle this back and forth. And that's one of the beauties of completely externalizing your application logic, is just the ability to do that.
This is blowing my mind a little bit. That I didn't realize that was there, and that's really awesome.
Technical question: is the events tied to your history configuration on the machine, or is it independent of that?
What do you mean?
So you can specify how long of a history you want your machine to maintain. Is the inspector?
Oh, so right now it's a little bit naive. I need to take the time to actually make settings and things like that. But right now it just keeps a history of everything. So you should be careful about using the inspector, at least until I update it. And for people who are already using the inspector and have been for a while, it's mainly the same as a couple months ago, which is because right now I'm working on an XState creator, which allows you to visually design state machines, using your mouse or drag and drop tools or whatever. And so everything from there is going to affect this inspector as well. So you're going to have a lot of updated visuals and a lot more cool things. So one day, I will get around to
I was just curious,
adding settings for that. So
one question I have is, so looking at the state machine, like the fact that it's all just one JSON object, like I'm curious how, like in my head, I'm thinking, well, at some point I'm going to need some custom JavaScript code to run when these states change. Is there a way like I could subscribe to events? Or I'm even thinking so you have in JSON there, the after 1000 do it. Like if that were an actual needed to do like a fetch call to a server or something, what would that sort of look like? And I don't need you to code out the whole thing. I'm just curious at a high level what that would sort of look like, because I'm having a hard time thinking through that in my head.
Oh, why not? It actually doesn't take too much. So this is where we get into invoking different machines or different actors, and this is actually very much based on the actor model. So if you're familiar with the actor model, which is also really old, I just like really old computer science concepts, but this is going to make a lot of sense. So instead of this after 1000, let's say that we have const save to server or something, and so this is just going to be a function that makes a new promise. Again, we're going to do that fake, just after 1 second. We're going to save that to set timeout, and we're going to just resolve, I guess, with nothing, and do
that works.
Yeah. So The way you would do that here is you would invoke the actor. And so that just works like invoke source, and then it takes the context and the event, but we're not using those at all. Otherwise, this session would be like much longer. So we're just going to save to server over there. And so this is our custom JavaScript that eventually, returns a value. So we could say on done, that goes to active. We don't need that saved anymore. So we're going to save that. Pause after 1 second, it goes back here. And you know what? Let's do our race condition. So if I click here and then go back, nothing happens. And you might be thinking like, oh, did you clean up the Nope, I didn't do any of that. I purposefully just made this a timeout run and didn't worry about cleaning it up or anything, because what's happening is this undone is a special event. And just like any other event, the way that state machines work is just events. So when we're in this inactive state, if we get that special undone here, we're not handling that event. So the state machine is going to be like, I'm not doing anything with that. I'm going to stay in my state, and everything is going to work just fine. But of course, you could also use effect and subscribe to the state here, and it also returns what's called a service. So you could use effect service.subscribe, and that gives you the state. So console.log state, and then over there you could run whatever JavaScript you want.
I see. So if you even if you wanted to just you probably could put your switch in there then if you still needed it for doing something very specific or something that wouldn't fit logically in the JSON up there.
Exactly. Yeah.
And there's like a lot of well-defined things. So for example, XState also has things like on transition. So you can hook into particular transitions if you particular transitions. There's a lot you can do because it conforms to the very old, well-trodden specification. I actually really like, David, you have a really good explanation. I don't remember if it's in your docs or where, but on thinking about how a promise, while it's an actor model, it's also like, you can think of it as a very primitive state machine. There's the state of it's doing the promisey thing, and then either it is done doing the promisey thing, aka it resolved, or it has failed to do the promisey thing, aka was rejected. And so it's kind of like a very primitive three possible states.
Right. Yeah. And so even over here, like the implementation of promises, this is promisejs.org. I think that's like the most official promise thing. Or actually, no, it's originally an answer on Stack Overflow, but it describes a promise as a state machine, and that's exactly what it is. So, but yeah, as you mentioned before too, there's a spec called Statechart XML, which was published in 2015. And this is a whole bunch of XML stuff, but I just want to say that XState doesn't really invent anything. It is based on this spec, and it tries to adhere to it as closely as possible. So it's not just a fancy state library where I add features on my whim. No, it all has to be based on this spec.
I did have one more question on the code. If you go up to that invoke block up there, is the trigger for that just anytime the state gets changed to saving, it just knows to do the invoke part of it automatically?
Yes. So once you're in the saving, this invoke is going to run for the lifetime of the state. So if you leave this saving state, then it gets cleared out, or it gets stopped, whatever is being invoked over there.
Okay.
So we talked a little bit about complex Boolean logic and if statements and whatnot. Like what kind of guidance would you give, knowing that it's a very slippery slope to just add one more if statement? At what point should a responsible developer quit adding if statements and begin implementing the state machine concept?
Well, personally, back when I was, first learning about state machines, when I was doing app logic, and I admittedly did use a lot of, if statements and whatever, eventually you get these really, really gnarly if statements where you're doing like if this and not this and, you know, this and not this, and like just huge statements where, you know, you don't exactly know what's going on. The number one tool that I would use is just pencil and paper. You would say, okay, you know what, let's actually outline what are the states that my app can be in. And typically that happens when you have more than 2 states. So you see how like our alarm over here, we had const is active, set is active equals use state false, right? But we also had saving. And so naively, you might do is saving. And then we have set is saving. And so you're doing this because you're trying to figure out, is it in the active state, is it in the inactive state, or is it saving? So you have a total of 3 states. However, over here, you have 2 times 2 equals 4 possible states, which means one of those states is probably wrong. And that would be like if you have active and saving.
Right. Yep.
And so that would be an example of an impossible state. And I actually see this all the time where you have is loading, is success, is error. And you could potentially have is success and is error at the same time, or even is success and is loading. And you might think, you know, oh, that's silly. Why would anyone ever have is success true and is loading true? But I've seen web applications where the data is definitely loaded, but that loading spinner is still there doing its thing. And you're like, why? And it's probably because they don't have, you know, robust logic to remove those impossible states.
Yeah, another good rule of thumb that I think should be applied is if related logic that's dependent on one another for the business rules or the behavior or the app logic is like dispersed and diffuse in the code base. So in your original example, you had business logic that was in your use effect, but then you also had a business rule that had to be defined in your on-click handler. And so, but that on-click handler had better be working the way it's supposed to, even though they're like not close to each other. And as your app is getting more and more complex, then it's going to be like, well, I don't even have a central location that's telling me how this stuff is supposed to work. Whereas a state machine very clearly articulates and interrelates all of the moving pieces of that.
Yeah. Typically, I see developers shove a lot of business logic in their event handlers. And honestly, if you think about real world devices, like a calculator, for instance, do you think that the equals button or the plus button has like a microchip computer inside that little button that does all the possible logic? No, like all that button is doing is sending a signal to like some sort of internal motherboard, like some central place. And, you know, it's that central place is what's doing the logic. And that allows you to be really flexible with when you call events and how you call events. I want to show one quick other thing, not over here, but just as an example, like I recreated the Android, timer with XState. And so this is also using a state machine as well. And the thing is, this is completely framework independent. And I wanted to see, like, can we actually get this running, in some other framework? So what I did was I copied and pasted that machine, and then I put it in Vue. And so this works pretty much exactly the same way. And in fact, because it's the same machine, you're guaranteed that it is going to work the same as the other machine. So we have the same timer machine here, absolutely nothing to do with Vue. And then once you go in your app, you see all you have are these send calls. And so when you reduce your app logic to just states and events that are sent from whatever, then the machine is sort of the brain of the component or the application. And, everything is reduced to just send events. So
your Vue code is just for viewing, and your business logic is just for business logicking, and things are where they're supposed to be.
Mm-hmm. Yeah. And kind of related to that, I'm wondering, I think a harder question in my head is, when do you think for Redux is kind of waning in the background, but use reducer is replacing it, or you might be using recoil if you need a more fragmented global state. So I guess for me, the question is when do you think XState is appropriate? When do you think it's actually not appropriate? Because that's another way that you can still centralize your business logic. You're using actions instead of your eventing on XState, but you could, like you were saying earlier, it's an inversion of a relationship. So I'm assuming it has to do with that relationship. So yeah, I don't know. What do you think?
Right. Well, I would say like when you're working on an application, if it's extremely simple, the use state hook is, great for just simple state. If you know exactly what you're doing and you know that the logic's going to be really simple. But then after that, you would graduate to use reducer. And that is something that I would definitely encourage first, just this power combination of use reducer and use effect. And typically what I would do is I would have my logic in use reducer, and then I would have use effect based on the state of, whatever comes from use reducer executing my effects. But even that could feel a little bit implicit. So after that, once your reducers and use reducer become really complicated, then I would say move to use machine and XState, because honestly, the API is exactly the same, say for this service, but instead of state send, you would have state dispatch, and otherwise it's exactly the same. Also, talking about Redux and recoil, the thing with Redux is it's a single global atomic store, which honestly, that's one of the things where Redux initially touted that as a benefit, where, okay, if you have many reducers, you combine them all into one single reducer and they all get the same event, but most of the reducers ignore the events that they don't care about. But XState is more decentralized. It's an actor model, so each machine is just localized to each of their components, or you could pass it down through context if you want. Yeah, so you have that, and also recoil. Recoil and libraries like that are still very manipulate the states. I almost want to say imperatively, and it pretty much is imperative. Recoil allows you to do that decentralization that I was talking about in an actor model-like fashion. However, your logic is still not very clear. You're not sending events. You are literally changing the state whenever you want, and recoil is just doing this magic in order to make sure that that's propagated to the components that care about that state. And that's fine if you're doing things like I don't know, drag drop applications, or applications where you have state that needs to be read by so many different things and there's not any complex transitional logic going on. But yeah, I would say treat XState like use reducer in a distributed fashion, not in an atomic global store fashion like Redux, but in a distributed fashion, just like recoil.
I can see a number of people wanting to give this a try, but they may face some resistance. We've had some questions stack up here in the chat. Let's let TJ get to those, and then I want to get your thoughts on how to sell this internally.
Okay.
Yeah, because we first of all, you've got some fans of XState in the chat. We've got some people that really like XState, and then oh man, it's a tradition here on the show that I always fail at pronouncing Twitch names. This looks like L1 Not.
I got Lynot.
Lynot. Okay, we'll go with Lynot. But big fan of XState, wants to introduce that in their company, and in the meantime, they've been using use effect reducer for a couple of features, and wants to know, is there any way of implementing the use effect reducer with an API that's more like the XState one?
All right, that's a great question. I actually don't really promote use effect reducer too much just because I'm lazy, but I created use effect reducer because a lot of people are doing this dance between use reducer and use effect, and they're finding limitations with it. Like you have to do a lot of defensive logic to make sure that your effects run at exactly the same time. And I just wanted to give it more of an imperative interface where inside your reducer, and this is going to look like blasphemy, by the way, but you get your state, you get your events. By the way, they call it action. This was a huge mistake by Redux. It's not an action, it's an event or a signal or a message. Just an action is something that's done like a side effect. So I use event wherever I can instead of action. It's an event. And also you get exec. And so this exec allows you to, as the name implies, execute side effects. So over here, I'm just executing this console.log going up, and I'm also incrementing the count. So this works just like a normal reducer, except with that exec as well. And so this allows you to be very precise about when your side effects are executed. Now, I know what you're thinking. Is this reducer pure? Yes, it is still pure, because internally, this effect or this exec doesn't actually execute this. Instead, it puts it in an array, and then use effect internally reads that array and says, oh, here's something I need to execute. And this is basically something that you would already be doing with use effect and use reducer. It's just combining the two in there. And so this, I actually created use effect reducer as a stepping stone to use XState, because exec is the same as an action, and your reducer state is would be the same as what you would define in a state chart with XState and with XState React. So,
well, there you go, Lynott. You're halfway there.
Yep.
Also, Lynott says they take pride on using use effect reducer and not use effect at all as well.
I really should promote this more. It's a tiny library. It's it doesn't really do anything too crazy. The TypeScript might be a bit scary, but that's because I'm using TypeScript. And it should be concurrent mode safe. I say should be because no one ever really knows for sure whether they're component. So, yeah.
Another question that came in from, oh man, here we go, Dan. Salo Aguars 89.
Aguiar 89.
Yeah, we need more John Does and Jane Does to watch React Wednesdays. But they want to know, how would you share a state machine between two components?
So sharing a state machine between two components is the same as like sharing, I don't know, basically anything else subscribable between two components. So use machine does return the service over here. And this service is an object that, again, you could call on transition, you could call subscribe to, you could do whatever you want with that. In fact, let's say that, I put this machine in the app instead, and I set the alarm service to service. I'm usually better at typing, but it's freezing over here.
I am the worst at it, so you're doing great.
So we get that in props, or alarm service. And then there's another hook called datesend equals use service alarm service. So use service is for an existing machine. And then I'm going to save. Oh, wait, no, did I do it right? Oh, wait. Yeah, service. I don't know. It's supposed to work. I might
what we made before, folks.
Remember, it takes.
Oh wait, it does work.
I was going to say it works.
Like it definitely should work. So that service you could think of as an actor, which you could basically pass to anything. So right now I'm passing it directly to this component, or I could use context, and just to show you that it is being shared. All of these are, using the same instance of the service. So basically simple as that. Use context or pass it in directly. That's how you share a machine.
So that's one machine shared across multiple components. I imagine like in a real world app, it's probably reasonable to have multiple state machines as well, right? Because there's probably like, I could see there being like an app state, but then a state for some other process, right? Especially if you like have like a dashboard like situation where you have lots going on. Would it be reasonable for multiple machines even to coexist?
Yeah, definitely would. And in fact, that's what I do already. In the inspector, all of this stuff, this is actually a React app. It's a Next.js app. And I'm using all sorts of different state machines, like, this panning behavior, different state machine for, just controlling the events and sequence and state, and even, just all of that. So yeah, you would.
Yeah, I think the question that TJ is getting at is from the architectural perspective, like where does one state machine begin and end, and where should another one begin and end?
That's honestly up to you. I like architecting my apps from a data first, perspective. Basically, I want to ask, what data do I need? What things can happen to that data, and structure it that way. And then I build my user interfaces around that. So I am using a lot of use service, use machine only when I know that the machine is for that component only. But yeah, it's basically the same answer as if you were designing something with Redux. Like, how do you organize your app logic so that that state is shared, amongst many components?
Right. Yeah, I think going back to the point before, it's what is actually related to itself. So that doesn't fully answer the question, but like if you need states that have to do with something that is not at all the alarm, then that probably doesn't belong in your alarm machine, because there isn't an inner relationship between states and transitions for those states. So you wouldn't want those to live in the same state machine. You'd want them in a separate one.
So,
right.
a state machine is kind of centralized around a concept in your application, a named concept, and drives that concept forward. And as long as, going back to TJ's dashboard example, if you had 15 charts, they could share a copy of the state machine, since, if you have chart view, table view, that's pretty straightforward. But if you had different charts that didn't have the same behavior, they would require different state machines.
Right. And I encourage, there's this real world app built by the Cypress team. Cypress is a testing library, and this uses XState and state machines all over the place. So if you want to see how a real world app works with state machines, this is a great repository to do so from.
And it's on GitHub. So
I just saw it in the chat.
The kind of question that I think people might have, and maybe not know that they have, is if they come back to their coworkers and say, yeah, XState, it's the exact thing that we need, they're going to run into the typical resistance that new ideas get, where someone doesn't understand it, so they kind of shoot it down. Like, what are the common objections that you hear when somebody wants to begin implementing XState, and what might someone say to help overcome those or broaden the conversation?
Well, a lot of the things is, like, first of all, XState, with state machines and state charts, you have a learning curve. But unlike libraries where you have a learning curve learning the library, this isn't so much a learning curve for the library. It's more of a learning curve for learning the principles behind state machines and state charts, and even the actor model. And those are really useful things to learn, even if you don't use XState at all. So that's definitely one of the objections, just, learning the stuff. And that's why, when I first introduced this, like the very first time, it went from like 7 GitHub stars to 9 GitHub stars over the course of 2 years. And I'm like, okay, people really aren't interested in this. But once I, showed the benefits, then, it got a little bit more popular, and people actually started realizing, fine, I'm just going to sit down, take an hour or two, and actually learn what state machines are, what state charts are. And then once you do, it's sort of this effect where you realize, okay, pretty much everything is a state machine, and I could describe so much app logic using these ideas. So that's why, like, just going back to the question, just convincing your coworkers to use this, I would not convince them to be like, hey, check out this XState library, go do this. I would more be like, can we try describing our logic using boxes and arrows? And then once I do that and my coworkers do that, they start thinking like, hey, this is a really clear way to describe our app logic. Everything makes sense. You just follow the arrow. It's all very visual. And then you transition from that to being like, are there libraries that actually do this?
And actually, there is one that we happen to know and like a whole lot, and it's free. So I think the message of the actor pattern is you get to encapsulate all the way up to the message level, and everything else sort of responds to that message the way it's configured to. So there's not a lot of leakage or things poking other things or causing side effects. Those were generally considered good programming practices.
Right.
The point about the kind of crazy if statements and conditional booleans is a good one. I don't know who likes to read that stuff, but it certainly is easy to write. And so, like, what sort of effort would it be? And I know this is going to be the it depends answer, but try to color it in if you can. Suppose someone has a reasonably complex application not using these principles. Like, is it a small undertaking, a medium undertaking? Is it like a crazy undertaking to get towards this model?
That's a good question where it definitely does depend. But I like XState and just state machines in general being a refactor target. And that's because, typically we build our logic from the ground up. Might not be the best idea, but it is the quickest idea for just getting that code in there and making the app work. MVP, there might be bugs, whatever, it works. And then from there, that's when you would start first just like containerizing or not containerizing, but like just encapsulating your logic into like only the logic that deals with the alarm service. We're going to group it into this and group other logic into other things. Really understand how the logic works in terms of states and events, and then convert each of those to a machine one by one. And so that's why with use machine, use service, all that, you're basically converting reducers that you would have written anyway into a machine. And that's why I say machines are just reducers with rules, right? So, yeah.
And part of that, to the point of it being like, it doesn't have to happen all at once. It can be iterative, and you can prioritize it in whatever makes sense for your project plan and everything. But on top of that, I think one of the hurdles, especially as your app becomes more and more complex, is one of the reasons to favor using XState in the first place, as we were talking about earlier, with all, not just if statements and complex if statements, but your business logic is strewn about, and it's almost definitely not documented by a technical business analyst. And so when you're saying, now we need to migrate this to something that's clear and coherent, it's like, well, I don't even know what the business logic is, because it's in our hundreds of thousands of line code base. It's in like
1,500 places.
Right.
Yeah.
And we not even have like edge cases that we haven't seen yet. Right.
Exactly. No, that's a very good point. And as we look at the pre-code here and the post-code, you can certainly see there's less room for weird errors to leak into production and cause that whole expensive workflow.
Yeah, we've had a couple of fun things come in through chat as well. Like Lynott said that did exactly that, just taking like pencil and paper and drawing out the state to show coworkers and even product owners, and also recommends Excalidraw, which is a fun little tool for drawing some of this stuff. And there's a couple other, I think one last good question. Also, Dan, you apparently got this name correctly. Boom. So congrats on that. But I thought this question might be a good one to wrap up on, because we're coming up towards the end of our time. Lynott's also curious, what are you expecting? What other tools can we expect in the following months? What are you working on? And I'd also maybe add on to this, for people that are new to XState, is there like a recommended spot you have for getting started as well? Is it just the documentation, or anything you think people should read?
Sure. So I'll answer the tools question first. So it's me and a couple other contributors just working on XState. Obviously, I have a full-time job, so I'm really only able to work on this on, just after work. And by the way, I do have GitHub sponsors, which I'm extremely thankful for, because that's really just something that pushes me to keep going. And so when I see like, oh, there are sponsors who are actually really thankful for my work, then, I just spend an extra hour or two each night and work on this. Not having kids helps, but so a lot of the things that I'm working on, we are working on a version 5 of XState. And don't be scared, the API is going to be pretty much the same here. There are going to be a couple changes like to invoke and things like that. But a lot of XState version 5 is just making full compatibility with SCXML, the spec, and also making it smaller, making it faster. The typical things that you would expect in a major release, with very few breaking changes. But if there are breaking changes, then that does merit a major release. So working on that, working on more visualization tools, like the thing that I mentioned, a drag drop editor. It's going to be called XState Creator, and it's going to be a way for you to create XState machines visually instead of doing so in code, even though doing so in code isn't really that hard. There's other projects too, like XState Code Gen, which if you've done XState with TypeScript, it's very hard to just to express everything that XState could do in TypeScript. But XState Code Gen does make that a lot easier. It automatically generates the types for XState, and so this does make it a lot easier to work with TypeScript in XState. There's a lot that I'm working on, version 5, the creator, that, and other tools. Yeah, just a lot.
And I think Christian might have touched on this, but I do remain excited about it. It's just the ability to pull out the state machine logic and show it to a non-technical user, whether that's a QA or a business analyst, or even like just a business partner who's a subject matter expert, and say, this is what I thought you said. Let's click through these and make sure that it responds the way that you want. And they can see this in a form that's intuitive enough for them to contribute back to you, versus, the other ways to do this are you show them the app and all kinds of stuff's in the way. And I don't know. I mean, I feel like that's kind of the unsung hero of all this is the separation of business logic and the ability to visualize it.
Well, and what David's currently working on, it sounds like even the non-technical people are going to be able to at least start scaffolding out the actual business rules using the visual generator, like the machine.
Right, yeah.
Run. Non-business people writing code.
And also the other way around. This is something where I'll just hint at it, because you might know that Reactathon is happening in a few days. And I am giving a presentation on auto generation of documentation. So the idea is that your state machine is a directed graph, mathematically speaking. And given that it's a directed path or directed graph, you could use things like shortest path algorithms to basically say, if I want to get to the active state, or if I want to get to a specific state, find me all the paths that go from the initial state to that state, and just generate documentation for them, or even generate the different states of the components as we go through each of those states. And then you have a very visual way of representing, like, hey, you want to go through an entire flow? Here's how to do it. And that's something that will stay up to date, whenever you change your machine, it's just automatically generated. So.
Very cool. And then if people do want to start, is it the documentation, GitHub? Where's your recommended path to get up and running?
So there's a few. There's of course the documentation on XState. I have here. There is I also over here I have a ton of resources, and these are just different demos and articles that people have wrote about XState. And I think there's like over 100, maybe like 200 over here, and they range from videos to other things as well. There's also statecharts.github.io, and this is written by Eric Mogensen. It's not XState specific. Instead, it's just a general introduction to state charts, the different parts of what state charts are, when you should and shouldn't use state charts, and all of that. And it's just a really good information resource. And there's also a community at spectrum.chat/statecharts, where for state charts in general, it's a really great place. A lot of people ask XState stuff over here, but there is also discussions on the XState repo itself. And you could get an idea of the kinds of questions that people are asking about, how do I use XState for this? How do I do this with XState? And yeah, there's just a lot of really good discussion over here as well. So there's a few places.
There's rumors of ports of XState into other languages like Python and Swift and so on. Can you kind of corroborate any of that?
Yeah, I am personally working on XState Python. It's not released yet, but it's basically the same idea over here. There is someone else working on Swift. One of a couple of my coworkers working on C#. And so they're not necessarily XState ports. You could think of XState is an implementation of the SCXML algorithm. So is XState for Python, and so is a bunch of other libraries too. So Yeah, the whole idea is basically, can we get XState or XState machines working in different languages and sort of testing that theory. So yeah, that's definitely happening too.
Excellent. Must feel nice to see your work spread beyond the original vision.
Yeah, yeah. And well, I wouldn't say it's my work. I'm just, spreading the word of like, hey, Statecharts exist. They've existed for longer than I've been alive. I'm just promoting it. At least in, JavaScript and the web. And I'm really glad to see other people who have either worked with Statecharts before or learned about it and are motivated to make it for other languages. So.
Well, we look forward to your love for old technology and can't wait to see Punch Cards 2.5 get released, David.
Oh, yeah.
Well, David, this has been like really, really awesome. I've definitely learned a lot. If people want to follow you, like reach out at all, is Twitter the best place? How can they follow everything you do?
Yeah, I would say Twitter is a good place to do it. I'm on there more often than I should be. So, yeah,
for sure.
It's at David K. Piano.
Okay, and I'll toss that in chat as well. Let's do that. And one thing we like to wrap up with is just any plugs that we have about various things, and it can be tech related or otherwise. Dan, you always like to go first for this.
Yeah, I'll throw out the newsletter again, the Enterprise React newsletter. What's cool is our developers are the ones who submit the article. So it's by developers, for developers, and we never spam.
I will throw that in chat. Christian, do you have anything else that you'd like to plug?
Nothing coming up.
David, anything you want to recommend here? It can be tech related or otherwise, or if it's just XState, that works too.
Yeah, sure. Besides state machines, I also really love doing animations, and I do it with my buddy Stephen Shaw, who works over at CodePen. And we have this stream called the Keyframers. It's not on Twitch, it's on YouTube. And so if you go to keyframe.rs, that's just a whole bunch of information. And a lot of the things we do are actually just like applying these state machine principles to doing these really complex animations. And I'm talking like, we'll pull animations from Dribble, like the ones that look really cool, and be like, let's see if we could recreate this in an hour or two. So
we've seen some of your CSS animations, and TJ and I both had to pick our jaws up off the floor. The CSS has always befuddled me, and I can't imagine ever making an animated wolf out of it.
Yeah, one day we're gonna have you on to just do an extended session on just how you do those, because I even feel like I'm usually pretty proud of my CSS knowledge, but when I see things like that, it's very humbling. Like it's using like a very niche way of using CSS that like my brain has a hard time processing and working around.
Yeah, that'd be fun.
It's even on some of those, like I have to change the code just to verify what I'm seeing is actually real sort of thing. Like if I remove the ear, does it actually remove the ear? And then it does. I'm like, dang it, it is real.
Oh, just one last thing, David. You did say you're speaking soon, right? What conference was that?
So that's at Reactathon.
Yeah, I'll drop that in there.
Get a link to that too.
In here as well.
Even more David K. Piano. Reactathon is the place to do it.
Mm-hmm.
And I'll just plug so we actually did a redesign of the React Wednesdays website. So I'll throw that in chat as well. So if you haven't seen that before, it's a pretty cool design. It's new. We've got videos of all the old shows. So if you want to look through, see previous streams that we've done. And also we do these every Wednesday, 1:00 Eastern, same clock we did this today. I don't have that on the website yet, but we have Joe Carlson from MongoDB coming on next week to talk some database stuff, which should be pretty fun. So check it out. We're here every Wednesday. So other than that, thanks so much, David. Again, this was really cool. Really appreciate you taking the time to teach us about state machines in XState.
Yeah, thank you all for having me.
Yeah, it's been great.
All right, guys. Until next week. See you, everybody.
Adios.